Hi, welcome back to this channel. In this video, we're going to discuss about chapter 8.5, Phenol. However, we will ignore the acidity in this video. We will combine this learning objective, acidity, when we enter the chapter of carboxylic acid. Okay, at where we're going to compare the acidity among phenol, alcohol, water, and also carboxylic acid. Okay, so in this video, we will focus on the chemical properties for the phenol, at where phenol will react with sodium hydroxide, and one more is missing out here, which is the acyl chloride, okay, which have the general formula RC+O+Cl. And then there is two identification tests for the phenol, which is the iron trichloride solution and also bromine water. As usual, we need to know how to give the name for the following phenol. So in question 1a, basically this one will consider as the parent name, which is the phenol. So, and then the phenol always will get the carbon 1. So this one will be carbon 2, 3, and 4. So we have chloro and also methyl. So based on the IUPAC rules, so we will follow the alphabetical order. That's why compound A should be 4-chloro, 2-methyl, phenol. Okay, so we highlight all the phenol structure first. So this is the phenol. Okay, this one also the phenol. So this is the phenol also. And this is the phenol for structure E. This will be the part of the structure of the phenol for structure F. Okay, then now we will focus on the substituent. As just now we say, this is first carbon, second, third, and opposite is the fourth. This one is nitro, and then this one is ethyl. So structure B is 4-ethyl, 3-nitro, phenol. While for the first structure, structure C, first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon. So we have bromo 2, 4, 6. Okay, so and then another one is fluorine. So bromo, fluoro. So even we have tribromo, but we will still considering the B. So that's why for this one is 2, 4, 6 tribromo, 3-fluorophenol. Okay, next continue with structure D. So carbon 1, carbon 2. So this substituent consists of 2 carbon. And then the second carbon consists of the hydroxyl group. So this one will known as 2-hydroxy ethyl phenol. Okay, structure E, carbon 1, carbon 2, carbon 3, carbon 4. So this substitute known as chloro, and then this substitute will known as benzyl. So benzyl and chloro, benzyl come first. So 4-benzyl, 2-chlorophenol. Last one, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So 2,6-dimethyl phenol. Let's proceed to tutorial question number 2. Now we're going to draw the structure. So all are phenol. So let's highlight the phenol first. Okay, phenol, phenol, phenol. Okay, however, D is not phenol. Okay, G and H is the phenol. Okay, so never mind. We start from question A. 5 isopropyl, 2 methyl phenol. So structure A, we have the phenol structure. First carbon, any carbon which attached to OH will be considered as first carbon. So second carbon, we need to have methyl, which is CH3, carbon 3, carbon 4, carbon 5. We're going to have isopropyl. So this is the structure for isopropyl. So for continue to B, we have phenol again. So attached to first carbon. Okay, carbon which attached to the OH will consider as first carbon. So O means is 1, 2 ortho. So the second carbon will have 2 hydroxyl ethyl. So ethyl consists of 2 carbon, and then there is 1 hydroxyl group at the second carbon. So this one will be CH2, and then this one also CH2. Okay, proceed to C. 2,4-dinitrophenol. So phenol again, we draw the phenol. 2,4, 2 is next to the hydroxyl group, which is NO2. And then 4 is the opposite side, also attached to the NO2. Continue with the structure D. 3-phenyl-2-butanol. The parent have 4 carbon. Second carbon attached to the OH. And then third carbon attached to the phenyl, which actually is referred to the benzene ring. So CH3, CH, CH, and CH3. So now proceed to E, benzene diol. So we draw a benzene first. Diol means that they have there are 2 OH, where is at the first carbon and also the third carbon, because it's 1,3 benzene diol. Okay, continue with structure F. We draw the phenol, followed by the OH, which is the first carbon, and then we have 2 chloro, 4 methyl, which is the opposite of the OH group, which will attach to the CH3. Next one is the G. This one is the G, and then now we go back to F. Yes. Okay. 2-phenyl-3-butane-2-ol. Butane again, 4 carbon. 2-ol means that the hydroxyl as the second carbon, double bond at the third carbon, and then 2-phenyl. So phenyl is the one with a benzene ring. Okay, so maybe I change the position of the phenyl and also the OH. Okay, so this one I attach to OH, and then this one I attach to the phenyl at the bottom here. So CH3, so this one will be CH and CH2, because each carbon going to have 4 bonds. Okay, last structure, which is the H. So we need to have a phenol, and then we have the OH, 2 benzyl, so will be CH2, and then attached to a benzene ring. Okay, and then 4 methyl, which is the opposite side. Okay, so these are the structure for A until H. Okay, before we discuss tutorial question number 4, so we need to have a summary, which is in between the alcohol and also the phenol. Okay, the alcohol, which we're going to highlight, alcohol and phenol. Okay, so main difference between alcohol and phenol is alcohol, we just focus on the phenol, which the OH group is attached directly to the benzene ring. So if we have any hydroxyl group attached directly to the benzene ring, so the OH group, this OH group will act as the phenol. Okay. So as we know that the Na, CH3COOH and CH3COCl, which is generally we say this is carboxylic acid and acyl chloride. When react with the alcohol, the alcohol will break the bond between R, O, and H. Means that the hydrogen will be taken out. Okay, if the alcohol react with the HX, PS3, PCl5, SOCl2 in pyridine, and concentrated HCl zinc chloride, the bond basically is break between R and OH. So when we can see the reagent KMnO4, Cr2O7, CrO3, PCC in CH2Cl2, we know this is the oxidation. While we see I2 in NaOH, this is the Lucas test. So basically we know that all these reactions can be carried out by alcohol. Only we need to remark over here, alcohol cannot react with the NaOH. Okay, not all the reaction carried out by alcohol will be carried out by phenol. Okay, so that's why we have to alert here. Na, sodium can, NaOH can, carboxylic acid cannot, acyl chloride yes. Okay, so and then basically we know that phenol will not break down the bond in between carbon, the benzene carbon, and the OH. Okay, this does not happen. Phenol also will not undergo oxidation. Phenol doesn't have the methyl carbonyl group. Okay, so that's why there is no reaction for the phenol if they react with the Lucas reagent, oxidizing agent, and also alkaline iodine. Okay, sorry to remark here, this one supposedly is we are in chapter alcohol, so because of here we will say there is no carbonyl. Okay, however, there is two identical tests. Okay, these two is the reagent that can react with phenol but cannot with the alcohol. Okay, so here we have a bit confusing. Some of the reaction will carry out by alcohol, some of the reaction can carry out by phenol only, and some of the reaction can carry out by both alcohol and phenol. So I think this slide is quite important, so please pay attention and also remember as well. So now we continue to next question. Okay, we are in tutorial question number 4. So this OH group, we will consider it as the character of phenol, while this OH group, we consider it is alcohol. So as just now we say that sodium will react with both phenol and alcohol. So the structure for the A after the compound X react with the sodium. So the bond will break between O and H. So O negative and N plus, CH2, 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 O negative and A plus. This is the answer for A. And then for aqueous sodium NaOH only will react with the phenol. Okay, so therefore the structure will become benzene ring attached to O negative and A plus. So because of alcohol will not react with the aqueous sodium hydroxide, so CH2, CH2, CH2OH will be remain unchanged. Phosphorus pentafluoride refer to PCl5. So for this one, the bond will break between R and OH, which involve the alcohol. So this is the structure for the answer C. Phenol maintained because phenol will not react with the PCl5. CH2, 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 since the bond is break between the carbon and OH, so the OH will be replaced by the Cl. Propanoic acid also only will react with the alcohol. So that's why the structure will become, the phenol part will maintain OH, and then for the alcohol will taken out the H, so CH2, CH2, CH2O. Okay, And then for the propanoic acid, which is CCC3 carbon, OH, CH3, CH2. For the propanoic acid, the bond will break between O carbon and OH. So means that this oxygen later will connect to carbon, double bond O, and then this carbon will connect to CH2 and CH3. So this is answer for the structure reaction D. Okay, let's proceed to tutorial question number 5. Compound 1 C7H8O. So when we read the question, we have to start to analyze the question. When we see the formula consists of O, so basically we can identify that the functional group of this compound Y is consists of OH. Okay, but as just now we say, the OH can be is the phenol or can be as the alcohol. So we need to keep reading the question to get the information. Insoluble in water, insoluble in dilute HCl, and also insoluble in NaHCO3. So far we didn't learn about this, so maybe we can ignore this information first. They say will dissolve in dilute aqueous NaOH. So this is the reaction that will be carried out by phenol. Okay, and then Y is treated with bromine water and then converted rapidly to C7H5OBr3. So again, from this statement, we also have the idea that the Y will react with bromine water. So if you still remember in the summary previously, which between alcohol and phenol, phenol is the one which will react with the bromine water. Okay, so another things that can support us is when you notice that the number of carbon is equal or more than 6. At the same time, the ratio carbon to hydrogen is almost 1 to 1. For example, carbon 7, hydrogen is 8. So if we make it to the mathematically, the ratio is 8 divided by 7. So we will get around 1.14, which is 1 to 1.14. Okay, which we consider it is similar with this. If this is the situation happen, so from this statement that we know that this compound consists of a benzene ring. So basically we already have the idea. Okay, just now we already identified compound Y is the phenol, and phenol supposedly will have a benzene ring. So here we already have the idea that the compound Y consists of a benzene ring, and then there is a OH group attached to the benzene ring directly. However, as we know, the benzene, the formula of benzene is C6H6. But here we have 7 carbon, means that there is 1 substitute which is consists of 1 carbon. So there are a few possibilities. This is the first one. Okay, and also there will be possibility the OH and then the CH3 attached to the 3rd carbon, and we also have another possibility, the CH3 attached to the 4th carbon. So if the CH3 attached to here, so we will number carbon 1, carbon 2, and carbon 3, means that we will going to anti-clockwise. So this anti-clockwise 1, 3 is similar with this 1, 2, 3. Okay, so that's why we know this is not possible. So here we have 3 possible structure. Okay, A, B, and C. Okay, before we discuss further about the question number 5, so we have just now we did mention that the phenol can react with the bromine water, okay, to produce white precipitate. Okay, So besides from writing Br2/H2O, we also can write Br2 aqueous. Okay, so if the bromine water react with the phenol, the color of the bromine, which is the reddish brown, for sure will decolorize. But then at the same time, white precipitate is formed. And the Br will attach to the second carbon, fourth carbon, and sixth carbon. So this white precipitate will known as 2,4,6 tribromophenol. Okay, so the position of the bromine is fixed, must be carbon 2, carbon 4, and carbon 6. Okay, beside from phenol will react with the bromine water to form white precipitate. Later in the chapter of amine, we have another compound also will show similar observation, which is the aniline with the benzene ring. And then the functional group for the amine is NH2. Okay, amino group. Okay, and then also bromine, aqueous, room temperature. Okay, so the bromine also will attach to the position 2, 4, and 6. So the side product similar is the HBr. The observation also white precipitate. So do keep in mind that basically both phenol and aniline, this is phenol and aniline, react with bromine water will going to give white precipitate. And then the bromine will replace the hydrogen at the position 2, 4, and 6. Okay, beside from the bromine water, the phenol also very specific, can react with the iron 3 chloride. Okay, the formula for iron 3 chloride is FeCl3. So basically, we also can consider that the reaction with the iron 3 chloride is the identification test for phenol. Okay, it means that basically among all the organic compound, phenol is the one which will react with iron 3 chloride. Okay, so as we look at here, the bond, because here is the phenol, will become the phenol side ion. So means that the bond will break between the O and H. As we know, the charge for H always positive. So O here supposedly is negatively charged. Okay, iron 3 chloride means that the charge for the iron is Fe3 plus. So that's why we consider like this. This is Fe3 plus. Okay, and then this one is negative. So we have 6 here. So plus negative 6 will equal to negative 3. So that is why the overall charge here is 3 negative. And because of this structure is complex, so basically we consider this is purple. That's why here we have the term complex, and then the color is roughly looks like this, which is the purple color. So the observation for this identification test for phenol with the iron 3 chloride is purple complex. Okay, after discuss both the bromine test, bromination, we're more to like bromination and the identification test for the phenol. So I think basically we have the idea that here we have 3 Br, so means that the later there is the OH, and then the Br will be at the position 2, 4, and 6. Therefore, if I have one substituent, the methyl substituent, basically it should be at the third carbon. So if this happens, the structural formula for Y will be 3-methyl phenol. Okay, if the question asks us to name this structure, is 3-methyl phenol. And write all the equation involved. So basically there are two reactions. one is react with dilute NaOH and another one is with the bromine water. Okay, so we continue with the B, the one with the dilute NaOH first. OH CH3 react with the NaOH aqueous. So this one, the bond will break between O and H, so will become O negative Na plus. And the methyl group will not react with the NaOH, so it will maintain CH3. Due to the bond is break between O and H, and then this one is Na plus and OH negative, so the side product is H2O. The other reaction, so we already done for aqueous, so another reaction is react with bromine water. So the 3-methyl phenol react with the bromine water, okay, which will give the product goes to the 2, 4, 6. And then here we have CH3. So for this one, again, the bond between O and H is breakdown, and then Br and Br is breakdown. So the side product will be HBr. So last question is we need to give one confirmatory test to the Y. So I will continue in next slide. Okay, so now we're going to give one confirmatory test for Y. So instead of bromination, we will prefer react this with FeCl3. Okay, so then we will have the phenol, 3-methyl phenol, okay, react with the FeCl3. So like just now we already know that the methyl phenol, the bond will break between O and O and H. So CH3 maintain. So make a bracket, we have 6, and then here is Fe. And then the bracket here will 3 minus. So, and then please write down purple complex. Okay, when it is confirmatory test, basically we need to have the reagent, and then we need to give the equation, we need to give the observation. Okay, so I think that's all for this video. Don't forget we have the tutorial question number 3 is not discussed because I will bring it to the tutorial carboxylic acid, and where we will discuss the acidity with the carboxylic acid as well. So see you again in the next video. Bye bye.